Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is the quadratic equation. What we are going to discuss today is drawing a linear and quadratic graph. So let's begin. After completing the very lesson today, my dear student, will be able to draw on the same axis the graphs of linear and the graph of quadratic equation. This is what I hope you will be able to do after completing the very lesson today. So as usual, my dear student, in your favorite segment of the lesson, today I want to tell you another interesting number, 131. This is another interesting, another special number. I'll tell you what is special about this very number after completing my lesson today. So don't go away. To begin the lesson, my dear student, let us learn the rule. It is this rule that we use as a guide in order to draw the graph of quadratic and the graph of linear on same axis. So let's begin. So the rule says first what you need to do is to construct the table of values for each of the equation. That is, you draw or you construct a table of values for the quadratic equation. And you also construct the table of values for the linear equation. When that is now done, step number 2 says draw and number the x-axis and the y-axis appropriately. When that is now done, step number 3 says plot and join the corresponding values of x and y in the table for the quadratic. Then next you now plot and join the corresponding values for x and y in the table of values for the linear equation. That is, you look at the table of values for the linear equation and also plot and join. It's good you now do one at a time, because if you plotted those points in the quadratic and you didn't join them, it will now be mixed up with the points that you have plotted for the linear equation. So that is why step number 3 says plot and join before plotting for the second table graph. So let's just move and take examples. Example number 1 says copy and complete this table for the relation. This is the relation y equals to 2x squared minus x minus 2. So this is a quadratic equation. This is the table. Some values, of course, for y is given. So it is where that is blank. We need to find what will now be the corresponding value of y there. Question number B says you draw the graph of that very equation, y equals to 2x squared minus x minus 2. Question number C says on the same axis, draw the graph of y equals to 2x plus 3. You can see this is a linear equation. So let's see solution to this very problem. So what the rule number 1 says we now do is to have a table of values for both the quadratic and for the linear equation. Let me do that. So starting with the table of values for the quadratic, you have a sample of it. I'm just to complete. Completing means where the value of y is missing, like in this place. When x is minus 1, I need to find it. When x is minus 2, what will now be y? This is the completed of this table that I'm asked to do here. So let me just do it. So substituting x by minus 4 in the given quadratic equation, 2x squared minus x minus 2, what I have finally after simplifying will give me the corresponding value of y there. So let me just do that. So if I now replace the x by minus 4, so 2 times minus 4 square, then minus 4 minus 2. So minus 4 square is 16. 16 times this 2 gives you 32. Then minus will give answer positive 4. Let me just write it. So you're going to have 2 times 16 plus 4 minus 4. This will now be 34 in the end. So the corresponding value of y when x is now minus 4 is now going to be 34. Let me write it. So I'll now move to this very place. This y is blank also. I'm now substituting x by minus 2. The same I did here. So let me just do it up it. So I will now replace the x by minus 2 in here or here, whichever one. So minus 2 square times this 2 minus 2 square gives me 4. 4 times this 2 gives me 8. And this minus 2 will now be plus 2. I have 8 plus 2, that will give me 10. And the 10 minus this 2, that will now be answer 8. So I'm going to write 8 here. So I'll move to this very point. I'm replacing x by minus 1 and finding the corresponding value here. So I'm going to have minus 1 square, which gives me 1 times this 2. I have 2. Minus 1 will now be plus 1. So 2 plus 1 gives me 3. And 3 minus 2, this will now be 1 finally. So I'm going to write 1 here. So I move to this very point. When x is 1, what will now be y? So I'm replacing x by 1. So I'm going to have 1 square, which is 1 times this to 2, which will now be 2. Then minus 1, 2 minus 1, that will give you answer 1. Then 1 minus 2, that in the end is now going to be minus 1. So this is how I complete my table. So when x is now 2 substituting correctly, what you are going to have, if you do it correctly, is going to be 4. Substituting x by 3 to get the corresponding value of y in here. If that is now done correctly, you're going to have 13. So my table is now complete. So what I'm going to do next is to plot this. Before plotting, I need to have my graph paper and draw and number my axis. Then I will be able to plot. So this is my graph paper. You try as much as possible to have a very large graph. That is to cover at least more than half of that graph paper. So let me draw the axis. Starting with the x-axis, look at the x-axis. So I'll now draw my vertical axis. That is y-axis, dx. So let me just number my axis. I'll now use this scale on the x-axis. That is, this is minus 1, minus 2, minus 3, minus 4. That is units for just these two squares. I must use the same scale in here for the positive part because it's same axis. So I'll move to the vertical axis. I'll also number it. I must have after this number 34, mind you. So let me just number it. I have this to 2 square. Each one is now 5 units. So 5, 10, 15, 20, up to 35. This is minus 5. So what I'm going to do is to now plot. So I'll start with this very first point where x is minus 4y is 34. When x is minus 4y is 34. So I'm going to find x minus 4 and y 34 appropriately. If this is y 30, this is y 35, there are 10 small divisions there in between. 10 small divisions, which means each 2 small division would now be 1. So to get 34 exactly, 34 will now be just 2 small divisions below this 35. That will now be somewhere here. So let me just mark it. This is my first point, x minus 4y 34. X minus 4y 34, look at it. So I'm going to take the second point, x minus 3y 19. X minus 3y 19, this is y 20. So this 2 small divisions below 20 will give me 19. So it's now going to be somewhere here. Look at it. Yes. So I'll continue. Next point is x minus 2y8. X minus 2y8. Y8 will now be 4 small divisions below 10. 4 small divisions below 10. So I'm going to have somewhere here. Look at it. Yes. So next point, x minus 1y1. X minus 1y1. So this is x1. This is y1. Somewhere just 2 small divisions. So I'm going to have it somewhere here. So next point is x0y minus 2. X0y minus 2 minus 2 will now be 4 divisions below this x-axis. So I'm going to have my mark there. Look at it. Then the next point, x1, y minus 1, x1, y minus 1 is going to be, have it like this. So I'll continue x2, y4. X2, y4 is going to be 2 small divisions below this line, having 5, 2 small divisions there below it. So I'm going to have it like this. So next is x3, y13. X3, y13. This is how we just mark, please. X4 last one, y26. Y26 will be 2 small divisions on top of this 25 and x4. So it's now going to be somewhere here. This is my plotting. So what remains is to join this set of points that I have plotted. And to join this set of points, you now used a broomstick, or you use your French curve, or you can use your free hand if you can draw it smoothly. Look at my drawing. Look at it. Yes, I would like to have a perfect curve. The reason is, if you are to get answers from this very graph, your answers will now be accurate. So this is the drawing of the quadratic graph. So we'll now move question number C. It says on the same axis, draw the graph of y equals to this straight line equation. So I need to have a small table for it. Then I'll plot, then I'll join. As this is just a straight line, 3 points are enough. So let me have a small table for it. Y equals to 2x plus 3. I just sample these extreme values minus 4 and 4 for x-axis. And I want to get the corresponding value for y there. So let me just do that. So when x is minus 4, substituting in this, I'll now have 2 times minus 4, which gives me minus 8. And minus 8 plus 3. That will in the end be minus 5. When x is 0, of course, 2 times 0 will be 0 plus 3. So y will be 3 there. When x is 4, 2 times 4, that gives you answer 8. 8 plus 3, that gives you 11. So this is my table for the linear. So I'm going to plot this as well. So I'll now start with x minus 4y minus 5, x minus 4y minus 5. Look at it, look at it, look at it. X minus 4y minus 5. This is the point. So next point, x is 0, y is 3. Y3 will now be just 6 small divisions here along the vertical axis. So it's now going to be somewhere here. Look at it, x0, y3. Then the last point, x4, y11. This is the point. So I'll now join these 3 points, 1, 2, 3, using my long ruler. This time around is long ruler because it's going to be a straight line. So using your long ruler, you now join these points. Look at my long line. So if one of the points happens to deviate from this line, which means there is an error somewhere. So this is my straight line, and this answered this very question. I have drawn the quadratic graph, which is this red curve, and I have drawn this straight line, which is this blue line. Now, this is the end of this very lesson, my dear student. I hope you find it resourceful. And let me just move quickly to the last segment, Maths is Fun, and explain what is interesting about the number 131. So it says 131 is prime along with all these combinations or other numbers using the same digits as 131. That is 113 and 311. These are two other numbers that you can have as a result of using those 3 digits 1, 1, and 3. These are the two numbers. That is the remaining two numbers, 113 and 311. And it so happens that these three numbers, 131, 113 and 311, they are all prime numbers. This is really amazing. So I doubt other numbers will give you this all combinations of numbers that you can have using those digits and all of them to be prime numbers. So we see more of these interesting things in mathematics in our subsequent lessons.